Hi guys, it is quiz day. Hooray. The quiz is over 6-1 to 6-4. I'm going to go over some questions from your 6-4 homework first. And then once we're done with that, I am going to record a video of the 6-1 to 6-4 review. I feel like some of you would probably prefer to just do it on your own or with a partner, and some of you would probably prefer to watch my video of it. So I'm not exactly sure what I'm going to have you do yet. I'm going to think through that in the next couple days here and let the sub know. So we'll see what happens after this. But we're going to start going over number 14 first here from the homework. Drag this over here. When you are solving a problem like this, okay, remember, as long as your base is the same, you're allowed to just add these exponents. So if you think about that, that's -3. 1/3 plus 1/3 plus 1/3 is 3/3. Well, another way to say 3/3 is 1, right? So -3 to the first power, this would be -3. That's probably how I would do that one. I feel like that one, that's how it makes the most sense to me. But if you did it a different way, that doesn't mean it's wrong. As long as you're getting to that -3, that's okay. Number 18, here's what I would do with this one. You have 3 to the 1/4 times 27 to the 1/4. So if you multiply that, remember, if your exponent's the same, you can multiply it. So the other way you could have done this one, right? They're all to the 1/3 power. So -3 times -3 times -3, that's a -27 to the 1/3 power. That's the cube root of -27, which is -3. That's what I'm going to do over here. So on number 18, I'm going to take 3 times 27, which is 81, to the 1/4 power. If we rewrite that as a radical expression, that's the 4th root of 81. Remember, on your calculator, you're going to go 4 math 5, and that will turn it into a 4th root, and then 81, if you don't know it off the top of your head, and that is 3. Okay, so that's number 18. Number 20 is x to the 1/5 power. I'm just going to do it right here because this doesn't take up a lot of space. X to the 1/5 power. Remember, the power is on top. The root is on, that's not how I want to write it. The power is on top. Oh my goodness, the root is on bottom. So this is a 5th root of x to the 1st power. You don't need that one, so we would just call it a 5th root of x. Okay, that would be number 20. 24, so that's t to the -3/4 power. First of all, we don't want negative exponents ever. So when you see the negative, you're going to flip it. 1 over t to the +3/4 power, and now you can think of it as a radical. So it's still going to be a 1 on top. Remember the power, so t to the 3rd power, and this is the root, the index. So take the 4th root of that. You can write it like that. You can write it like that. Okay, they're the same thing. I like this one better because, less stuff there, but that's up to you, what you prefer. Okay, number 28. How about? It says write each expression in exponential form. So now it's the radical, and we're trying to turn it into the exponent. This one we would do, it's a square root, right? And there's 2 pieces here. Okay, we want to simplify both and put them both into exponential form. So a square root, remember, whenever it's a square root, it's a 1/2 power. So this is going to be 7 to the 1/2 power. And then x, and again, it's basically saying x to the 3rd to the 1/2. Well, we can just multiply those. So it'll be x to the 3/2 power. So that is your simplest answer, 7 to the 1/2 times x to the 3/2, and you'll just leave it like that. Okay. You know what, let's do number 30 while we're at it, because this one is very similar. Notice this and this. I just want you to see the difference here. So it's taking this whole thing, the square root of 7x, to the third power. So if we simplify it, basically we're saying 7x to the 1/2 power, right, is the same as this. But then we need to take that whole thing to the third power. So this one is actually 7x to the 3/2 power. You don't need to distribute that 3/2 to both of them. That's what the parentheses is doing for you. So you would just leave it be like that. Okay, 34, you have the cube root of 5xy to the 6th power. Now for this one, you are essentially going to take everything 5xy to the 6th power and then take the cube root of that. But you can also think of it like this, okay? This is a third root, a cube root, and it's to the 6th power. Because we're taking everything to both of those things, you can right off the bat write it like this: 5xy, the whole thing, to, now think about what power that would be. This is power over root to the 6/3 power. So really it is just 5xy to the 2nd power, okay? Now if you distributed this first and then took the third root, the cube root of everything, you would get there. That's fine. This is just one way to get there. So when we simplify this, 5 squared is 25, and then we have x squared and we have y squared, and that's as simple as you can go with that. That will be your answer. All right, moving on. Number 48. So 64 to the 2/3 times 64 to the 2/3. The way I would probably do this is I would add my exponents here because we have the same base, okay? I would probably make this 64 to the 4/3 power. And then from there, what you can do is break it down into radical form. So this is going to be the cube root of 64, and then take that to the 4th power. So if you were to plug this into your calculator, the cube root, so math 4 of 64 is 4, and then take 4 to the 4th power, and you get 256. Okay, I would love to see that you got to this point and then gave me your answer rather than just plug this whole thing into your calculator. I want just to know that you're understanding the process. So just show me what you're doing along the way. That's helpful. Okay, number 50, you have a negative 32 to the 6/5 power. So remember, root on bottom. So this is a 5th root of negative 32. And then I'm going to take that whole thing to the 6th power. And again, you can do it the other way. You can take the 5th root of negative 32 to the 6th power if you want, but that gets you a really big number to 5th root. I would rather do it this way because I know without having to plug it into my calculator what this is. If you don't, that's okay. If you want to plug this into your calculator, you do math 5 and then negative 32, and then hit enter, and you get negative 2. Okay, so this is negative 2 to the 6th power. Don't forget those parentheses if you're going to plug it in. Negative 2 to the 6th is 64. So this would equal 64 on number 50. Okay. Let's see. 56. Oh, this one's fairly lovely. You have a negative 4/7. Sorry, super blurry. Negative 4/7, and then we're taking it to the 7th power. So you can just multiply those powers right there. When you do that, you get x to the negative 4th power, right? The 7 over 7 is 1. X to the negative 4th is 1 over x to the positive 4th power, and that is your answer. All right, almost there. I'm gonna do 2 more with you, and then we'll do the worksheet. Oh, this is terrible. I don't even know what those are. I think this is 2/3, and this looks like 1/6, and -12. Sorry, apparently I didn't take very good pictures for you. Okay, so for this one, you have a couple options. It's a -12th power. You could flip the whole thing right away and make it a positive 12th power. That's what I would do. I like to get rid of the negative right away. So I would go 1 over, and now I'm going to distribute a positive 12 to both of these, right? We're going to ignore that because we're flipping it to the bottom. So x to the 2/3 times 12 would be 24/3, right? Which you can just write as 8 right off the bat. I'm just doing it for those that want to see it this way. And then y to the 12 over 6 would be the second power. Sorry, 12 over 6 if you want to see where I'm getting it. So you would get on this one, oh, this is not what the book is saying. I missed something. I think maybe there was a negative. Oh, there's a negative right there. Shoot. Okay. If you do it the way I did it, missing the negative, it would be x to the 8th, y to the 2nd. Apparently, this is a negative. So if you saw that negative when you did the problem, then that would actually have to stay on top. So it would be y to the 2nd over x to the 8th. But again, that's however you saw the problem. If you saw the problem the way I did, without the negative right here, this is your answer. If you saw the problem with the negative, this is your answer, okay? Technically, this is the correct answer, but I don't know what that looked like in your book pages, if it was clear for you or not, so my apologies. Okay, 64, x squared over x to the -11th, and taking everything to the 1/3 power. So if we simplify this, I would probably, what would I do first? I would probably do this first. Okay, they're both x's. So 2 minus a -11 is actually going to turn your thing here into 2 minus a -11 is a positive 13. So x to the 13th power to the 1/3 power. Okay. And then from there, now all you have to do is multiply those. So that's x to the 13 over 3 power, and you're done. Okay. So that is just going over some of the homework questions. Hopefully that made sense to you. Why don't you take a quick little stretch, move around break, and the sub can tell you what you're doing from here, since I haven't made up my mind yet today. It's only Tuesday for me, and you're doing this on Thursday. So I'm going to think through if I want you to just do the worksheet with me, or if you're going to do the worksheet in groups, and then whoever wants to watch the video could watch it on their own. We'll see. Take a little break. Okay, so the review 6.1 to 6.4, this kind of talks you through like each section at a time. So the first section, 6.1, that was roots and radical expressions. Basically finding the real nth roots of something. So what we're gonna do, it says simplify each radical expression if possible. So number 1, this is where we broke it down into the perfect and the not so perfect. So starting with this guy here, we're going to break that down into what perfect square is 96 divisible by. Again, if you're stuck on how to find this, you are literally going to plug into your calculator. Remember we did all the perfect squares, 4, 9, 16, 25, 36, 49, 64, 81, and 100, okay? You're going to take that 96 and you're going to go 96 divided by and figure out what makes sense. 100 doesn't make sense. 81 doesn't make sense. 64 doesn't make sense. if you're not sure, maybe start here. 96 divided by 49, not a whole number. 96 divided by 36, not a whole number. 96 divided by 25, not a whole number. 96 divided by 16 is, it's a 6, okay? So 16 and 6 is what you would do there. And now remember, your index, your root is a 2. So this number needs to be divisible by 2 to be a perfect square. So we're going to take the next number below that to make it an even, x to the 4th. And then this is going to be just 1x left over, x to the 1st, which you don't need the 1. Y to the 8th, we can take all of that. So it's going to look like this, and now we simplify. So the square root of 16 is 4. The square root of x to the 4th is x squared. The square root of y to the 8th is y to the 4th, right? You're just dividing by that number each time. And then you have the square root of 6x. Okay, so that would be your answer on that one. Number 2, this setup, if you take 216 and you divide by 8, you actually get 27. So I would do that first, the cube root of 27, x to the 4th, and then simplify that. So we can actually take the cube root of 27, but we can't take the cube root of x to the 4th. So cube root of 27, this is technically a 1 on the other side. You don't need to write that in. This would be x to the 3rd to be able to divide by 3, which means you have 1x left over here. So simplify that. Cube root of 27x to the 3rd is going to be 3 times x, and then you still have the cube root of x over here. So this is your simplest answer. Okay. All right, number 3. This one's a 5th root. And some of this you can take 5th root of and some you can't. If you're not sure on the number, try it first. So this would be 5, math, 5, 32. Check. Can you actually take a 5th root of 32? You can. That works out to 2. Okay, so the whole 32 is going to go on the perfect side. So yes, we can take a 5th root of that. Can you take a 5th root of x to the 3rd? No, you cannot. Can you take a 5th root of z to the 5th? Yes, you can. So that's the perfect one. Okay, so now do it. 5th root of 32 is 2. The 5th root of z to the 5th, remember you're just doing z to the 5 over 5. That's a 1, so you're left with a z. And then you have the 5th root of x cubed. So that'll be your answer. Okay, so that's 6-1 material. Then we have for 6-2, multiplying and dividing radical expressions. Okay, it says multiply or divide if possible, then simplify. You cannot have radicals in the denominator ever in a final answer. So make sure if there is one in the denominator that you rationalize, you get it out of there. Did you want to say hello, Kenzie? Oh no, she doesn't want to say hello. She just wants to sigh. Okay, number 4. So we're going to first do some multiplication on this one. If we multiply these two things together, because they're both square roots, we can do that. 40 times 8 is 320. And then x to the 5th times x squared. You're just adding those together, x to the 7th. And now let's break it down. Okay, so again, think about what perfect square is 320 divisible by. And you might think of 16 here because 32 times or divided by 2 is 16, right? So it's tempting to go, oh, it's 16 and what would that be? 16 and 20, but then the 20 would have to be broken down more. Okay, mommy's recording, okay? So instead, look a little higher. That's why I always say start high and work your way down. 64 actually works here. So if we do 64 times 5, we get 320. That's a better answer. And then x to the 7th, you're going to do x to the 6th so that we can divide by 2. Because remember, these are both 2's. And then that would leave us with 1x over here. Okay, so simplify that. Square root of 64, you get 8. The square root of x to the 6th, you get x to the 3rd. And then it's times the square root of 5x. And that is your final answer. All right, number 5. This one, cube root of all of that. We're going to simplify by multiplying it together first. So the cube root of 16 times 2 is 32. X to the 5th times x to the 3rd. You add those together, x to the 8th. And then y to the 4th times y would be y to the 5th. So now break it down. Perfect cubes, not so perfect cubes. So for 32, now remember it's cube roots. Remember cube root y is 2 times 2 times 2. We get 8. 3 to the 3rd power, you get 27. 4 to the 3rd power, you get 64, sorry. And so on and so forth. So that's what we're looking for. 32 is divisible by which of those? Well, it is divisible by 8, and it's 8 times 4. Okay, now this, x to the 8th, has to be divisible by 3 also. So the lowest, or the highest under 8 that we can go is going to be x to the 6th, which means you have x squared left. And then your last one, y to the 3rd, is going to leave you with a y squared over here. So now from here, simplify what we can. Cube root of 8 is 2. This is x to the 6 divided by 3, so x squared. And then y to the 3 divided by 3 is y to the 1st. And then you take the cube root, don't forget this guy, he gets left off a lot, of 4x squared y squared. And that is your answer. All right, number 6. Divide this first. So this is going to be the square root of 36. This is x squared, right? You just subtract. So the square root of 36 is 6. The square root of x squared is x, and you're done. Quick one. All right, number 7 here. These ones we have to rationalize. Remember when we rationalize, especially when it's a cube root, this one's kind of high, we want to make it something when we multiply these two parts that we get a perfect cube right here. Okay, so think about it this way. It's going to be something over itself, first of all. So this is an x squared. If we want to take a cube root, we would multiply by x to get x to the 3rd. Okay, this is y, so we would want to multiply by y squared to get y to the 3rd. So that means this is going to be xy squared here. And now we can multiply across. So up top, you have the cube root of 3xy squared. Okay. On bottom, we can actually take that cube root for both of those. So our numerator is still going to be this. But our denominator, the cube root of this, is just x times y. And that is your answer. Can't simplify your x's and your y's there because one's in a radical and one is not. So leave it like that. All right, this one. I would start this one just simplifying as much as we can first. So can't get rid of the 5 or the 2. So it's still going to be 5 and 2, but this is going to be x squared up top, and this 3 minus 1 is going to be y squared on bottom. So now when we try to simplify, we can actually take some square roots here. The square root of x squared is x, but we still have the square root of 5. The square root of y squared is y, and we still have the square root of 2. So now this is a much simpler problem than if we were just to try to multiply by all of that, okay? Instead, we can just multiply by rad 2 over rad 2 to get rid of that denominator radical. So up top, you have x times the square root of 10. On bottom, rad 2 times rad 2 is 2, and we still have the y. And that is your simplest, okay? Okay, if you're watching this video as an entire class, I don't know if you are or not because I haven't made up my mind. But if you are, stop, pause, take a little stretch break, move around a little bit. It's been a little while. All right, I took my break. On to 6-3, number 9. We are going to simplify as much as possible, and then just keep in mind, no radicals in the denominator, so we got to ditch those eventually, if there are any. So number 9, this first one, we cannot add radicals that are different. So we need to simplify our radicals here first, and then we can keep simplifying from there. So this is going to be what's a perfect square, what's not, what's a perfect square, what's not. Don't forget our friends out in front, the 5 and the 4, okay? So 16, that would be, 32 would be 16 and 2, and then the x has to go here on the non-perfect side because we can't take the square root of that. 98 is divisible by the perfect square 49, which leaves us with 2x. So simplify that. 5 times the square root of 16 is 5 times 4, so 20 times the square root of 2x, plus this is 4 times 7, so 28 times the square root of 2x, and when you simplify that, you get 48 times the square root of 2x. Okay, number 10, what do we do with that? Really wish I could hear your answers right now. That'd be way more fun. These ones, be careful. It almost looks like they're conjugates, but they're not, because this, right? One's plus, one's minus, but you also have a 2 in there that you don't have on the other one. So they're not conjugates. You can't use a shortcut. Instead, you're going to have to FOIL it. So the square root of 3 times the square root of 3 is just 3, right? Square root of 9, which is 3. Square root of 3 times 2 rad 7 is a positive 2 rad 21. This is a negative rad 7 times rad 3, so minus rad 21. If you want to put a 1 in front of there to help you remember it's 1 rad 21, you can, you don't have to. And then our last, you have a negative rad 7 times 2 rad 7. So that's going to be minus 2 rad 49. Okay. So simplify that. 2 rad 49 is 2 times 7, right? So it's minus 14. So you have 3 plus 2 rad 21 minus rad 21. So that's going to be plus rad 21 minus 2 times 7. And then just simplify that. 3 minus 14 is a negative 11 plus the square root of 21. That's as far as you can go. Don't combine those because one's a radical and one is not. All right, and then number 11 is the one that you are going to multiply by the conjugate of the denominator. So it's 2 plus rad 3. We're going to multiply by 2 minus rad 3. 2 minus rad 3, so on top and bottom, okay? If it helps you to visualize it with parentheses around those, you can do that too. On bottom then, this is the shortcut. Remember the shortcut? It is a squared minus b squared. So for the shortcut here, you're going to take your a value and square it minus your b value and square it, right? So basically what we're doing here for our denominator is 4 minus the square root of 3 squared is 3. So you should be getting a denominator of 1, which is nice, which means you don't even need to write it as a fraction in the end because it's over 1. Up top, we need to FOIL. So it's going to be first is 8. This is not going to fit well. I'll try and squeeze it. Minus 4 rad 3, remember, because this is minus 4 rad 3, plus 2 rad 6, And then this is going to be the square root of 6 times the square root of 18. And it's minus the square root of 18. Okay. So you have all this. Well, we can simplify the square root of 18 to the square root of 9 times the square root of 2. And like we said, this is all over 1. So you could put it here, but you're still going to simplify it further to just that number by itself. So 8 is our only whole number. Then we have a square root of 3, we have a square root of 6, and we have a square root, so this is 3 rad 2, a square root of 2. None of those are combinable. So your answer is going to be 8 minus 4 rad 3 plus 2 rad 6 minus 3 rad 2. And there's nothing else you can simplify about that. It's all over 1, so you don't need to put it over 1. Just leave it like that. All right. Okay, home stretch, 6-4. So this number 12, we're going to just simplify this expression. 3 to the 1/3 times 9 to the 1/3. We're going to think of that as the cube root of 3 times the cube root of 9. Okay, well, what that is then, if you multiply these, you get the cube root of 27, and the cube root of 27 is 3. Okay, remember cube root in your calculator, math 4 is cube root. You're welcome to plug that into your calculator if you can't remember it. 13 says convert from exponential form to radical form or vice versa. So we're just switching the form that it's in. Remember the root is on bottom. So this is your root or your index. This is your power. So this is going to be a 4th root of y to the 3rd power. Now you may write that 3rd power inside here, or you may write it outside like that. Okay, either one is fine. Okay, letter B. It's x to the negative 9/8. So we're going to start by flipping it. So 1 over x to the positive 9/8, and then use your power and your root to rewrite this. So this is going to be an 8th root. Let's move it over so I have room here. Here, we'll go here. 1 over the 8th root of x to the 9th power. And again, write it inside, write it outside, but this is not your simplest form right now, right? Technically, you could break this into the 8th root of x to the 8th and the 8th root of x to the 1st. So really the best way to write this one, I'm running into my other one here, would be 1 over the 8th root of x to the 8th is just x. And then this we can't do anything with. So 8th root of x, and that will be your simplest answer. Okay, letter C, sorry about the mess here. This is the square root. Remember, that makes this a 2. So if we're going to write this in the rational form, because it's already in the radical form, we're going to turn that into x to the 7 over 2 power. And that's all you have to do with that one. Okay. Okay, letter D here. The 9th root of x to the 3rd, if you rewrite that rationally, you take the power divided by the root. So 3 divided by 9, which would be x to the 1/3 power. Ooh, polka dots, sorry. Okay. Okay, last thing. Number 14 says write these expressions in simplest form. So that's what we're going to do. We're going to take the cube root of both of these things. So it's the cube root. Remember, it's the 1/3. That's a cube root of negative 27. And then this would be x to the negative 9 times 1/3 is a negative 9/3. Okay. Better way to write that would be a negative 3 power. So this is negative 3 when we take the cube root of negative 27, and then x to the negative 3rd. Well, this is going to move to the bottom. Remember, this does not. That -3 doesn't move your 3 anywhere. You still have a -3 on top, but then x to the positive third power on bottom. Last one. Okay, letter B here. I'm going to distribute that -6 to everything first. So this is going to be x. -6 times 1/2 is a -3rd. And then this one, you have a -2/3 times a -6. So that's a positive 12/3. Okay. So what that does is that x to the -3rd is going to move down, x to the positive third. Y to the 12/3 is y to the 4th, and that stays on top because it's positive. And that is your answer. Okay. Happy quizzing. If you have any questions, ask your neighbors. There are people around you that know how to do this. Ask them for help. They are capable, and it's good to learn from each other. So that's all I got for you. Good luck on the quiz.